All right, so this video will focus on 4.3, and if I look here, the very first thing I'm doing is comparing numbers. And we did this back a long time ago in chapter 1. So go through here, pause the video, and try to figure out which number is greater or less than. All right, so hopefully you went through and figured that out. Let's check if you were right. All right, so make sure that when we're working with negative numbers, it's kind of like counterintuitive. It almost seems opposite, but it's the closer to 0 for negative numbers, the greater the value is. Our essential question, how could you use multiplication or division to solve an inequality? What's nice about this is basically chapter 3 with solving equations, and we're just putting that inequality sign in. So if I look here, I have 4x is greater than 12, and it's saying decide which graph represents the solution of the inequality. So I'm going to first of all put in the table and see what the values are. So if I take this here, if I take 4 times negative 1, I get negative 4. This is 0. This is 4, this is 8, this is 12, 16, and 20. This one here, 4x is greater than 12. So if I look here, this does not work, does it? Negative 1, because that would be, that's not greater than 12, this is 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 not. But when I start getting anything larger than 3, so if I get a value larger than 3, it does seem to work. And 3, of course, does not work itself because it says greater than, not greater than or equal to. So if I look here, this is the one that actually works. We're going to do the same thing now, but now try it with this one. So I'm going to plug in the various values, and if I look here, this is 15. This is 12. This is 9. This is 6. This is 3, 0, and negative 3. And now it's saying, let's see if it's less than, right? So is 15 less than 9? No, none of these are, but notice that this is less than or equal to. So basically, it's like right here, all these values here will work. So which one of these graphs here determine or show these answers? If I look here, I have negative 3, and it has to be a closed circle, which they both have. And then which value will be the one that I'm looking for? And if I look here, it's actually this one right here, isn't it? So this one says add 3x to both sides. So it says solve this by adding 3x to each side of the inequality first, then solve for the resulting. So if I look here, let's just try this out. So if I have negative 3x, I'll write it on this side. So I have negative 3x is less than or equal to 9. And it's saying, first of all, add 3x. So I'm going to add 3x to this side. Well, the only problem with doing this is that I have nothing on this side now. So I just have 3x plus 9. So I have 3x plus 9, and I have this here, and there's nothing on this side. So what I'm going to want to do is I'm going to want to actually subtract 9 from both sides. And now I have 3x, and I'll do the 1/3. And I'll have x is greater than negative 3. Now let's see if this works. So if I plug this in, if I do negative 3 times negative 3, I do get negative 9. So that works for the equal to, right? I like that part a lot. So I'm going to graph this out and put negative 3. And I'm going to put a closed circle above it. And now let's see if we can do another one. Let's try the 0 test. I like doing a 0 test. So what is negative 3 times 0? Well, that's 0. And is 0 less than 9? And the answer is yes, it is. So I'll put 0 here. So we'll go in this direction here. Right, so x is greater than negative 3. Here we go. And that is the answer. Now it says to compare my solution, which I have right here, with the one that I just did in 1b. If I look here, here's the exact same equation that we just did a moment ago. And if you look here, I actually get the exact same answer, don't I? I start at negative 3 and goes to the right. So now let's try this one here. And I have x divided by 3 equals 1. So let's do this one. And so the very first thing I want to do is I want to plug this in. So negative, so this would be negative 1/3, 0, 1/3, 2/3, 3/3 or 1/2, 4/3, which is 1 1/3, and 1 2/3, right? And then we'll go here and see which one is less than 1. So basically everything here is less than 1, like all these values here, right? So it would be anything less than 3. 3 would not count. So you'll notice that both of them have the open circle at 3, which is right because this does not count. But it seems as though it's going anything to the left or getting smaller, right? So it would be this value here. And let's do a similar thing here. So I'm going to go through and have this plug in. So I have negative 5/4, or so I'll have 5/4. This here would be 1. This would be 3/4, 2/4, or 1/2. This is 1/4. This is 0. And this is negative 1/4. And I'm basically trying to make it so it's larger than positive 3/4 or equal to. So it's all these values right here. So it's anything that is negative 3 or smaller. So all these values work right here. And it says use the table to solve the inequality. Let's go through here. So the first thing, if I have negative 2x is greater than or equal to 10. Let's just first move the x to make it a positive x, right? So I'll say plus 2x, plus 2x. Again, I'm now going to have 10 plus 2x is greater than nothing, so I have to subtract 10, right? And minus 10 on this side. And I'll have 2x is greater than or equal to negative 10. So then I'll do my multiplicative inverse. And I'll have x is greater than or equal to negative 5. And so that's the first one. And then I'll just keep on going. And basically what I'm doing is I'm first of all just adding this over. And let's do c next, because I think that's a very important thing to show you. I'm not breaking them up, and that's why I can add or subtract these variables, or these coefficients. So let's try x over negative 4 is less than 1. So the first thing I'm going to do is I'm going to add. So I'm going to add x over 4 here. I'll rewrite it, and now I'll have x over 4 plus 1, and that's here, but now I have to move that variable over, right? So I'll say minus 1. Rewrite it, and I'll have minus 1, and I'll have x over 4. I gotta do the multiplicative inverse, which is times 4 over 1 times 4 over 1. So x is greater than negative 4. And let's just try that out. Make sure that it works. So I plug in a 0. I really like doing a 0 because it's so easy to do. 0 divided by negative 4 is 0. And 0 is definitely less than 1. So I start at negative 4. I put my open circle. I try my 0 test to see if it works. And it does, so it goes this direction. All right, so now we're going to solve these inequalities. So it says use a table to solve. So pause this for a moment and give this a try. And we have x is negative 2. X is greater than 2. X is greater than or equal to negative 6, or to 6. X is less than or equal to negative 6. X is greater than negative 63. And finally, x is less than negative 5/2. So make sure this is what you have. So the key idea here is that when you multiply or divide each side of an inequality by the same positive number, the inequality remains true. So if I multiply, like let's say here, both things by 2, it's still a true statement, correct? And if you divide, the exact same thing happens. It still stays as a true statement. So we're going to solve this here. So x divided by 5 is less than or equal to negative 3. Well, if I multiply this by 5 over 1 and this by 5 over 1, I'll have x is less than or equal to negative 15. And that is the statement. That's true. And then I have to graph this out. So I start at negative 15. It's a closed circle because it's less than or equal to, and it goes to the left. So graph this one here. So this is n divided by 3. Just so you know, another way to write this, where I think it might be easier, is n over 3 is less than 1. So again, I do the multiplicative inverse, which is 3 over 1. And now I'll have n is less than 3. I'll graph it out, put my 0, put my 3. It's an open circle, and it goes to the left because it's less than. And here are the other two for you. Notice for this one, you first will, or you'll just multiply, you'll just multiply it by 10. So you'll get negative 5. This one here, I'll multiply it by 3 halves. So that'd be 9, so that'd be 4.5, or 9 halves. Graph this solution. So I have 6x is greater than negative 18. Again, you just do times the multiplicative inverse, so 1/6. This times 1/6, and you get x is greater than negative 3. You then will simplify or solve it, I should say, graph it. So I'll have a negative 3, and it will go, it's getting bigger. So the negative 3 does not count. It'll be an open circle, and it'll go to the right. So open circle, and it goes to the right. So give these a couple a try. Pause the video and try solving. You should get this. This right here says multiplication, division, property of inequality, case 2. It says when you multiply or divide each side of an inequality by the same negative number, the direction of the inequality symbol must be reversed. So what we've been doing so far is we've been changing the side in which the variable's on. So for instance, I want to show this to you. Let's say that I had negative 4x is greater than 16, right? And what we've been doing in the past, I'll solve this two different ways, but really pay attention, is we've been first adding 4x to both sides. And then I have 4x plus 16 is just less than nothing. I then have to move over the 16. So really I'm just switching sides here. Do you notice that? And I'll rewrite it, and I'll have 4x is less than negative 16. I'll do the multiplicative inverse. And I'll have x is less than negative 4. And that's my answer. So let's see what that would look like in terms of a graph. I'll have my negative 4. I'll have like negative 5. And I'll put a 0. I know that it's an open circle. Now I got to figure out which direction it will go in. So I always apply the 0 test. Is 0 less than negative 4? It's not. So if I put a 0 in here, that is not greater than 16 up here either. So 0 does not work, so it's got to travel this way, right? Now that's one way to solve this. The second way to solve this, which is a little bit shorter but requires you to pretty much, a lot of people kind of lose context as to what they're doing, is just this. It's negative 4x is greater than 16. I'm going to multiply by 1 over negative 4 and 1 over negative 4. Now watch what I have to do here. This is really important. I'll even change the color. This sign, in order for this to work, has got to flip. Oh boy, don't make it that big. Let's try it again. It's got to flip. So it's got to go this direction. And now I have x, positive x, is less than negative 4. Notice I got the exact same thing that I got up here. But on this one, at least, you can kind of see why it's happening. On this one, you're kind of taking a leap of faith, and you're just saying, because I'm dividing, I have to flip the sign. And you don't really know why. So this property, this special case number 2, is saying, hey, there's definitely an easier way to do this. You could just flip the sign. However, realize what you're doing. And I've got to say, over my 15 years of teaching, this is where people make a big mistake because they don't really know why this is working. So I really encourage you, until you get good, to do it this way because you see it. So now go through and practice doing this way. We're just going to flip the sign. So again, you go through, we have it. I'm going to multiply by negative 2/3, but when I do that, I'm also going to flip the sign. Watch. See how I flip the sign? Multiply by negative 2/3. This will now be negative 12/3 or negative 4, right? So n is greater than negative 4. But I mean, you just got to pay attention to how I flip the sign. So this is a special case thing. Here's another one. Try it again. Again, I'm going to multiply by a negative 3. By negative 3, that becomes a 12 on this side, but I have to flip the sign. So it's going to be x is less than 12. This one here, again, I'm going to multiply by 2 or negative 2, but you're going to flip the sign. This one I'm going to multiply by just 5/6. The sign stays the same because it's not negative. And this one here, the sign will flip because it's a negative when I multiply by negative 5/2. So let's look at it. So here we go. Notice how the sign flipped, the sign flipped, the sign flipped, and the sign stayed. Well, actually, this one should have stayed the same. I see, I'm sorry. So the sign didn't switch, it's just that now you're solving for m. See how the m was on the right side before? They just moved it to the left side. So the sign doesn't flip really. It would still be m is less than or equal to, in this case, negative 10. It's just they flipped it as m is less than or equal to negative 10. Graph these out, give it a try. Here are the steps. And then finally, here's the last one I want you to do. So in this case, I have to multiply by negative 5, right? Or divide by negative 5, which flips the sign. So it'll be z is greater than negative 7. This is going to be a is less than, you're going to flip the sign, and we'll say 4.5. This one here, it'd be 1.5/3, right? So it'd be n is greater than 1/2. And this one here goes into 42 6 times, right? Or 4.2. So it'll be, but I have to flip the sign, so it'll be w is greater than 6. So let's look. Boom. And that's all of them. And that is the lesson. Sorry, it's a longer one, but it makes sense.